Hello YouTube family, let's prevent a solution given this nice algebra problem, which is a to power 2 subtract a cubed. This is equal to 150, so this is the value of a. Now solution, we have a to power 2 subtract a to power 3. This is equal to 150, alright? So let's take 150 on the left hand side so that we'll have a squared subtract a cubed subtract 150. This should give us the value of 0. All right, so this is the same thing as 8 squared subtract a cubed, so subtract 150. 150 can be expressed as 125 plus 25. All right, or rather 25 plus 125. This should be equal to 0. All right, so that we'll have a squared subtract a cubed subtract 25 can be expressed as 5 to power 2, all right, subtract 5 to power 3. This is equal to 0. Now from what we have here, this is a to power 2 subtract 5 to power 2 subtract a to power 3 subtract 5 to power 3. This is equal to 0. Now we have the first part, which is a squared subtract 5 squared subtract. Now we can express this as a cubed plus 5 cubed. This is equal to 0. Now as you can see, the first part, this is actually the difference of two squares expressed as a squared minus b squared, which can be expressed as a plus b, a minus b. All right, so we have a squared subtract 5 squared, which you can express as a plus 5 and a minus 5. Now the second part here, this is actually in the form of a cubed plus b cubed. Okay, so let's express it. We're saying that we have a squared minus 5 squared minus a cubed plus 5 cubed. Now we're saying that the first part is the difference of two squares expressed as a squared minus b squared, which is expressed as a plus b, a minus b. So a squared minus 5 squared, this is the same thing as a plus 5, a minus 5. Now this is the first part. The second part, which is a cubed plus 5 cubed, this is actually in the form of a cubed plus b cubed, which you can express as a plus b, a squared minus ab plus b squared. Okay, so let's apply this property. So we have a cubed plus 5 cubed, which is a plus 5. Then we'll have a squared minus 5a plus, this is 25. All right, now let's combine the first part. Okay, the first part here is a plus 5 and a minus 5. So you'll have a plus 5, a minus 5, subtract, okay, a plus 5, a squared minus 5a plus 25. This should give us the value of 0. So that's from what we have here, a plus 5 and a plus 5 is common. So we factor out a plus 5. Into the parentheses, we'll have a minus 5, subtract. Now, the second part here, we have a squared minus 5a plus 25. This is equal to 0. Now, we have two parts here. We have a plus 5 into the parentheses. This is a minus 5, subtract a squared. Now, plus 5a, negative times plus 25, this is negative 25. This is equal to 0. All right, now that means we have two parts. The first part is a plus 5 is equal to 0, and the second part is a minus 5 minus a squared, which we can express as this is negative a squared, okay, plus a plus 5a, this is 6a, subtract negative 5 minus 25, this is negative 30, this is equal to 0. All right, now let's multiply by negative on both, so that we'll have a squared subtract 6a plus 30, this is equal to 0. And this is a quadratic equation whereby we have a is equal to 1, b is equal to negative 6, and c is equal to 30. Okay, so let's solve this quadratic equation. Now we have the quadratic equation, which is a squared minus 6a plus 30 is equal to 0, with a equal to 1, b equal to negative 6, and c equal to 30. All right, now let's calculate the discriminant value, which is b squared minus 4 is c, so that you can be able to assess the nature of the root of this square root, this quadratic equation, sorry. So let's substitute the value of b squared, that is negative 6 squared, subtract 4 times 1 times 30, all right? Now this is the same thing as, this is 36, negative 6 1 is 36, subtract 30 times 4, which is 120. So 36 minus 120, this is negative 84, which is less than 0. And that shows that we have two complex roots. All right, two complex roots. All right, so let's solve, for us to solve this complex root, actually that is a2 and a3, we apply the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, divide all this by 2a. Now let's substitute this. Negative b, this is actually negative times negative 6, plus or minus the square root of b squared, which is negative 6 squared, subtract 4 times 1 times 30. All right, divide everything here by 2, so that we'll have 6, negative times negative 6, this is 6, plus or minus negative 6 squared, this is 36, subtract 120, divide this by 2, so that we're going to have 6 plus or minus the square root of negative 84, divided by 2. All right, so let's proceed. We have 6 plus or minus the square root of negative 84 divided by 2. Now we can express this as 6 plus or minus. We can express the negative 84 as 4 times 21 times negative 1. Divide this by 2. All right, so that we'll have 6 plus or minus. Now the square root of, this can be expressed as square root of 4, this is equal to 2, square root of negative 1, this is I, and then square root of 21, divide this by 2. All right, so if you simplify here, you're going to have 3 plus or minus square root of 21 I. All right, so now we have two complex roots here, that is a2 is equal to 3 plus square root of 21i, and a3 is equal to 3 subtract square root of 21i. All right, now these are the two complex roots. Okay, these are the two complex roots, and you're seeing that we have two complex roots here, that is a2 and a3, and a1, which is negative, a1 is equal to negative 5, as you can see. This is a real root, right? Now let's check. Okay, let's check if this real solution satisfies the equation. Now remember, we had that a squared subtract a cubed, this should give us a value of 150. Now let's substitute this. This is negative 5 squared subtract negative 5 cubed. Okay, let's see. Negative 5 squared, this is equal to 25. Then we'll have negative 5 cubed. This is negative times negative 125. This should give us 150. Okay, sorry. We are saying that we have here negative 5 squared subtract negative 5 cubed. This should give us 150. So negative 5 squared, this is 25, subtract negative 5 cubed, which is negative 125, and this is equal to 25 plus 125, which is 150, and this is equal to 150. So the left hand side is equal to the right hand side, and that affirms that the real root, which is negative 5, actually satisfies the equation. So thank you for watching. Follow the steps and kindly like this video and subscribe. See you in the next video. Bye bye.